Hi there, Year 5, it's Mrs. Flavell here, and I thought it'd be nice to do a geography lesson based on earthquakes. We've done one on volcanoes, so it would be good to do one on earthquakes. Now, remember, we're starting to do some quizzes at the end of each week now for literacy and numeracy, and there'll be one starting next week for the other topics like science, geography, and history as well. So be aware of that and look out for them because there might be some questions on this in those quizzes. Okay, so we'll read it through and we'll have a look at some questions on it afterwards. Hope you enjoy it. What causes an earthquake? The Earth has four main layers: the inner core, the outer core, mantle and crust. The crust and the top of the mantle is like a puzzle made up of many pieces. These puzzle pieces move around, sliding past one another and sometimes bumping one another. These pieces are called tectonic plates. The edges of the plates are rough and can snag on other plates while the remainder of the plates continue to move. This movement causes faults or areas of stress where crushed rocks along the edges of the plates move in relation to one another. This causes a break in the surface and energy release, and the energy released moves in waves through the earth. This is what causes an earthquake. The diagram here shows how the Earth's plates are made up. The red lines are where the plates all meet and move around. So the Earth plates are always moving. They move so slowly that we usually can't feel it. The edges of the plates are called faults. Faults can rub together, push towards each other or pull away from each other. Have a look at the Earth's plates. What do you notice about where New Zealand is? You will find that the plate that goes right the way through the middle of Iceland, which is up at the top, is actually pulling Iceland apart, and Iceland will soon be two islands and not just one. Types of faults. There are three main types of movement along the fault lines, and the diagrams help to explain this, and you can see how they move. We've got a strike slip. This is where is a lateral or side to side movement. Dip slip, that's the normal one. Vertical movement, which involves the overhanging or overlying rock moving downwards in relation to a lower block. And a dip slip reverse or thrust. Vertical movement, which involves the overhanging or overlying rock moving upwards in relation to a lower block. These are the ones that occur underneath the sea and can cause tsunamis. Interesting facts. There are around 7 large and several small tectonic plates making up the surface of the Earth. The study of earthquakes is called seismology. Seismometers measure the vibrations of the Earth during an earthquake. The magnitude and intensity of shaking is reported using the Richter scale. This scale rates the earthquake between 1 and 10, with 1 being hardly noticeable and 10 being widespread devastation. The depth of an earthquake and the type of fault also has an impact on the amount of damage that is done. Some earthquakes can occur under the ocean, resulting in a tsunami. The epicentre of an earthquake is the location directly above where the earthquake originated. How strong it is. There are two main ways to measure the power of an earthquake. Machines called seismographs, pictured to the right here, measure the power of an earthquake at its epicentre on a scale called the Richter scale, named after the person that invented it. Another measure is the Mercalli scale, and this is based on people's observations during an earthquake. This is what people observe, what damage they observe has happened during the earthquake, and they measure it that way. Comparing earthquakes. Okay, the Mercalli scale, the intensity, the effect. A 1 is felt by no one. 2, felt by very few people. Hanging objects may just swing a little bit. Number 3 is felt by many, but they don't realise it's an earthquake. Number 4, Felt indoors by most people, vibrations similar to a lorry hitting the building. Number 5, felt by nearly everybody, sleeping people may be woken, trees and telegraph poles might sway. Number 6, felt by all, people run outside, furniture moves, slight damage to property. Number 7, felt by all, people run outside, moderate damage to buildings, that might be chimneys falling off or walls cracking. Number 8, specially designed buildings could be damaged and others might collapse. Number 9, all buildings damaged, cracks appear in the ground. Number 10, many buildings are destroyed. Number 11, almost all buildings are destroyed and wide cracks in the ground. Water, gas and electric is affected and out of action. And number 12, total destruction, the ground moves in waves or ripples. You notice these are always numbered in Roman numerals. This is where your maths comes in, kids. Right, let's see how much you have picked up on earthquakes. So let's look at our questions. Have a look at the questions, have a go back at answering some of them, and then we'll go back through the answers. What are the 4 main layers of the earth? How is the crust made up? What is the name given to these pieces, and what happens if they collide or rub together? Can we feel the movement of the earth's plates? What are the edges of the plates called? What are the 3 main fault types called? What is the study of earthquakes called? What is the magnitude of an earthquake measured on? What does the scale go up to? What can an earthquake under the ocean cause? What is the location above the earthquake called? What does the Mercalli scale go up to? Where does the most seismic activity take place on our Earth? Right, what are the 4 main layers of the Earth made up of? Okay, so they are the inner core, the outer core, mantle and crust. So, inner core, outer core, mantle and the crust. You probably remember this from when we were learning about volcanoes. Okay, and how is it made up? It is made of pieces that are called tectonic plates. So it's pieces like a puzzle called tectonic plates. What is the name given to these pieces and what happens if they collide and rub together? So the edges of plates are called faults. Okay, so the tectonic plates edges are called faults. Okay, so these fault lines rub together and push towards each other. Okay, so can we feel the movement of the Earth's plates? The Earth's plates are always moving. They move so slowly that we usually can't feel them. So usually we can't feel the movement of the tectonic plates. We only feel movement if they collide or brush against each other to cause the earthquake. So, what are the edges of the plates called? Well, they are called fault lines or faults. Okay, and the 3 types of uh, fault are strike slip, okay, where they slip forwards or backwards, the dip slip, where they slip down from being above, and then there's the dip slip, which is the reversal thrust, where it slips from being underneath and up above. So one might slip down, and then another time might slip back up again. So it might be a dip slip normal, and then it might be a dip slip in the reversed or the thrust. So that's how the plates move all the time. So the study of earthquakes is called seismology, okay? And seismometers measure the vibrations of the earth during the earthquake. It's like a little needle on a piece of paper that feels the senses of the earthquake and draws a line to how strong that earthquake is going to be. So the magnitude, that means the power of the earthquake, is measured on the Richter scale. Okay, so I measure them on seismometers, and it is measured on the Richter scale, which goes up to 10, which means that the 10 is the strongest and meaning widespread devastation. Right, an earthquake under the ocean can cause tsunami. So, tsunami happens normally if the ground slips, okay, underneath the ocean, and the displacement of the water here causes large waves above the ocean, and these large waves push towards the land, okay, so they're going towards the land and cause the land to flood, and that is a tsunami. That's the best diagram I can draw, really. So what is the location above the earthquake called? So the epicentre. So the epicentre, so where the slip happens, the earthquake happens, the part right above it on land there, that is called the epicentre. A little diagrams there to try and help you understand. Right, what does the Marcelli scale go up to? Well, again, here it goes up to 12. That's 12 in Roman numerals. That's where our mass comes in. And most seismic activity on our Earth. But it did ask you to recognise around New Zealand. And here is New Zealand, as I'm drawing a ring around it. And there is a lot of plates that are active there. And New Zealand gets a lot of earthquakes. We then have a place called the Ring of Fire. And the Ring of Fire, which is around here, a lot of seismic activity takes place there. There is a lot of seismic activity that takes place between the continents of Europe and Africa. Okay, so there's a lot that goes on there, and there is a fault line, goes all the way up from South America, and it continues all the way up to North America and Canada and Alaska at the top. And this fault line is called the San Andreas Fault up to this part here, okay, and that is very active. There are a lot of earthquakes in North America, certainly in California, and certainly in Alaska. They are very active areas. Right, some fun facts about earthquakes. The largest earthquake ever recorded in the world was in Chile in 1960, and it measured a 9.6 on the Richter scale. The largest in the US was a 9.2 magnitude in Alaska in 1964. They can cause huge waves in the ocean called tsunamis. Movement of tectonic plates has formed large mountain ranges like the Himalayas and the Andes. Earthquakes can happen in any kind of weather. It doesn't matter. The weather doesn't affect whether an earthquake is happening or not. Alaska is the most seismically active state and has more large earthquakes than California. Can scientists predict earthquakes? Unfortunately, scientists cannot predict earthquakes. The best they can do is point out where fault lines are so we know the earthquakes where they're most likely to occur. They can also predict if there are quite a few tremors acting on the on the seismographs, and if they detect these going off quite regularly, it's a sign possibly that a bigger earthquake is going to happen. So they do get monitored all the time. Right, there are some extra questions here now on fun facts about earthquakes. So number one, where was the largest earthquake ever recorded and how much damage would have this caused? Number two, what is a tsunami? Number three, what can be formed from the movement of tectonic plates? Where is the most active state where earthquakes happen? And five, can earthquakes be predicted? Have a little check back over the information that is on fun facts about earthquakes, and then we'll get back on these questions. So, where was the largest earthquake ever recorded? The largest earthquake was in Chile, which is in South America, which I mentioned is a really active place, okay, and it was 9.6 on the Richter scale. So, thinking about the Richter scale and what it told us, 9.6 is actually not far off a 10, which being widespread devastation. It actually grounded ever such a lot of buildings. It was very, very severe earthquake indeed. Okay, and a tsunami, well, a tsunami, as I said earlier, is where the land has slipped underneath the ocean. So there's an earthquake that has slipped the ocean, and the displacement of that land causes causes a tsunami. So the water is pushed up, causing huge waves to come in towards the land. So, what can be formed from the movement of tectonic plates? Well, large mountain ranges. So, the mountain ranges are formed when two plates push up against each other. Okay, so the most active state where earthquakes happen, well, Alaska is the most active. They're getting earthquakes and tremors pretty much all the time. And over the last few years, I've had quite a few large ones measuring 6.5, 7.5 on the Richter scale. So those are quite big. Can earthquakes be predicted? No, they cannot be predicted. As I said earlier, they can detect whether there are lots of tremors going on in an area which might trigger a bigger earthquake, but they don't quite know if the big earthquake is going to happen. And no, weather doesn't affect these earthquakes at all. So, hopefully, that's given you a bit of an insight into earthquakes, something that I really enjoy teaching about. I love the the geology, I should say, of our Earth and how it works. Right, now you might want to think about researching more amazing facts about earthquakes. There's absolutely loads to research. So if you actually visit the Natural History Museum in London, which you might get to do in year 6 if all this lockdown appears to disappear and trips go on again, you can actually see an earthquake simulator which shows you how intense each magnitude of earthquake is on the Richter scale. Maybe you could find some video footage of when an earthquake takes place. Quite interesting to watch. A bit scary as well sometimes. Britain does get earthquakes, but they are very rarely felt. And I have only ever experienced 4 earthquakes in my 21 years of life. So, yes, we do feel them sometimes, but they're nowhere near on the scale as the rest of the earth sometimes feels them. Hope you enjoyed this, kids. Stay safe, take care, watch out for those earthquakes.